Good morning, chemistry students. We are finishing up our Chapter 8, Section 2 notes, focusing today on combustion reactions and predicting products of a chemical reaction. We're going to start with combustion reactions, and again, we're going to start with our definition. The definition of a combustion reaction is an element or a compound reacts with oxygen often producing energy as heat and light. So in a combustion reaction, an element or a compound reacts with oxygen, often producing energy as heat and light. So this part about reacting with oxygen, remember combustion kind of means to burn, okay? So think about one of the ways that you can put out a fire. To put out a fire, you can smother it. What are you doing when you smother it? You're depriving it of the oxygen that it needs. So all combustion reactions are going to require oxygen as a reactant. So as always, our first step is to talk about our reactants, how many of them there are, and what they are. So for our reactants, again, hopefully looking at our definition, you can see that we're going to always have two. Okay. And, okay, it's usually a hydrocarbon which is just a compound that contains carbon and hydrogen and oxygen. And remember, because we're talking about oxygen, it's an element all by itself, which means it's a diatomic molecule O2. Okay, so for reactants, for combustion reactions, we always have two. Typically, it's going to be a hydrocarbon. You're going to know it's a hydrocarbon because it contains carbon and hydrogen. And it's always going to have another reactant, which is oxygen. The products. Again, the products are usually CO2, carbon dioxide, and water, H2O. If it's complete combustion. And unless it says otherwise, you will always assume it is complete combustion. If by chance it says otherwise, if it happens to say in your textbook that it's incomplete combustion, then your products will be carbon monoxide and water. But again, unless your book specifies or the problem specifies incomplete combustion, you will always assume it's complete combustion. Okay? We only do this if the problem says incomplete combustion. Okay, so combustion reaction, we're always going to have two reactants, a hydrocarbon typically in water. We're always going to have two products, carbon dioxide and water. Usually, if it happens to be incomplete combustion, it would be carbon monoxide and water. For combustion reactions, you must be able to predict the products because, again, they're pretty easy. Predicting the products of a combustion reaction, it's going to be carbon dioxide and water. All right, as you have seen on some of our ChemQuests that we've done already, these tend to be the most difficult equations to balance. So here are some tricks. The first trick is to do, or we'll say balance, carbon first. Then balance hydrogen. And the reason we typically do hydrogen next is because hydrogen is only in one spot in the products instead of in two spots. Okay? If for some reason your oxygen hasn't worked out, if you need an odd number of oxygen, then you're going to put that odd number that you need over 2 as your coefficient on oxygen, and then multiply all the coefficients in your equation by 2. Tends to be faster than trying to find that number some other way. Okay, so these are the tricks for balancing combustion reaction. Start with carbon. After carbon, balance hydrogen. Now, if you need an even number of oxygen, it's not a problem because you typically have O2, okay? But if you need an odd number of oxygen, when you have a 2, that makes it difficult. So you're going to take that odd number that you need, you put it over 2 as your coefficient in front of oxygen, and then you multiply all your coefficients through by 2. We're going to do 2 examples, so in your space on your outline for examples, make sure you have room for 2. The first one, the sentence is the combustion of heptane, which is C7H10. So our word equation for this, because again, we want to go to a word equation to get rid of extra information, is going to be heptane. Our other reactant we always need, even if it doesn't say anything about it, we have to have oxygen for anything to combust or anything to burn. And this doesn't say anything about it being incomplete combustion. So our products are going to be carbon dioxide plus water. So now that we have our word equation, now we're ready to write our balanced chemical equation. Again, we want to make sure we're leaving space in front of our formulas to allow room for coefficients. So starting with our heptane, which was C7H16, plus oxygen, which is O2 because it's diatomic, carbon dioxide, CO2, plus water, H2O. Okay, so now I'm ready to balance this. I have my skeleton equation right now. 7 carbons, 1 carbon, I need a coefficient of 7. 6 hydrogens, 16 hydrogens, and I have 2, so I need a coefficient of 8. So now I'm looking at my oxygen. Right here I have 7 times 2, which makes 14, plus 8 more here, gives me 22. I could get 22, that's an even number. I need a coefficient of 11. I think I'm balanced, I'm going to check it. So 7 carbon, 7 carbon, 16 hydrogen, 8 times 2 makes 16 hydrogen. 11 times 2, that's 22 oxygen. I have 14 oxygen here, plus 8 more here gives me 22 oxygen. This is properly balanced. Our second example, we have the combustion of ethanol. Again, we're going to start with our word equation, which is ethanol plus, again, we have to have oxygen, even though it doesn't say anything about it. So I have to have oxygen for something to burn. My products are going to be carbon dioxide and water because, again, it doesn't say anything about it being incomplete combustion. So now that I have my word equation, I'm ready to go to my skeleton equation. So my skeleton equation for this is my ethanol, which is C2H5OH, plus oxygen, which is O2, yields CO2 plus H2O. So there's my skeleton equation. Now I'm ready to balance it. I have 2 carbons, I have 1 carbon, I need a coefficient of 2 in front of carbon dioxide. I have 5 and 1 makes 6 hydrogen. I have 2 hydrogens, so I need a coefficient of 3 in front of water. I have 3 oxygens here. I have 2 times 2 is 4, plus 3 gives me 7 oxygen. So what's a little bit different here is I have 2 oxygen here and 1 more here. So to get 7, I just need a coefficient of 3 in front of oxygen. Now I have 7 oxygen altogether. So if I check this, 2 carbon, 2 carbon. 5 plus 1 makes 6 hydrogen. 3 times 2 makes 6 hydrogen. I have 6 plus 1 makes 7 oxygen. 2 times 2 is 4. Plus that 3 gives me, again, 7 oxygen. This is correctly balanced. All right. Our last part here is about predicting the products of a chemical reaction. So what you're going to see now on homework and such is all you will be given are the reactants, whether that's in a sentence form or whether that's formulas, okay? They'll just give you reactants and expect you to be able to predict the products. To be able to predict the products, the first thing you have to do, the most important thing, is that you must recognize the type of reaction. So just kind of reviewing real quick, we have our combination reactions. And again, all we want to focus on right now is what do we see for our reactants? Because all we're going to see here, if we have to predict the products, all we're going to see and be given are reactants. Okay, so all we're going to focus on right now is what do we see for reactants in a combination or synthesis reaction? Well, if they're asking you to predict the products of it, all you're going to see for your reactants for a combination reaction are 2 of them, and they're both going to be elements. And one's going to be a metal, and one will be a nonmetal, so that you produce an ionic compound. Okay? So, again, if it's a combination reaction, you're going to have 2 elements reacting. Okay? If it is a decomposition reaction, Again, and they're asking you to predict the products. Then they're going to give you, remember decomposition, we have a single reactant. And it's going to be binary, meaning it's going to be made of only two different types of elements. So those two different types of elements are just going to decompose into their elements. Okay, so let me give you an example. These two in particular, you often won't be asked to predict the products of. But if you are asked to do one, let's say maybe a combination one, then maybe the reactant that they're giving you, reactants might be lithium and chlorine. Well, this is a metal and a non-metal, so the only compound I can produce is lithium chloride. And because it's an ionic compound, you do symbols, charges, crisscross, lowest whole number ratio to get its formula. Okay? Again, typically for decomposition reaction, you won't very often be asked to predict the products. But if you are, again, it's going to be a binary compound decomposing into its element. For example, you might have sodium chloride. The only thing sodium chloride can decompose into are its elements sodium and chlorine. And you know how to write those, so then you can balance it. Okay? Oftentimes, again, you won't be asked to predict products of combination or decomposition unless they're these two simple type examples. The next kind of reaction that we talked about was our single replacement reactions. Again, how are we going to recognize that we have a single replacement reaction? Remember, in a single replacement reaction, we have two reactants, always an element and a compound. And remember, with single replacement reactions, there's sort of a little extra step before you predict the products, because you have to check and see that the element by itself is higher on the activity series of metals or higher in group 17, the halogens, than the similar element in the compound. If it is higher, go ahead and write your products. If it's not, remember you're going to write no reaction. So occasionally for a single replacement reaction, you might write no reaction as your products. All right, our next type of reaction is our double replacement. Again, how do we know that we have a double replacement reaction when we're only looking at our reactants? Again, we're going to have two reactants, but this time our two reactants are two compounds. And remember, in a double replacement reaction, the cations, the positively charged ions, are switching partners. Okay? Lastly, what we just talked about today were our combustion reactions. You're going to know a reaction is a combustion reaction because you're going to have that hydrocarbon. And sometimes there's not even going to be oxygen listed as a reactant, but you have to add it. Okay? So you'll know a combustion reaction because you're going to see a hydrocarbon, that carbon and hydrogen containing compound. You'll have to add the other reactant, oxygen, and our products are always going to be CO2 and water unless it happens to say it's incomplete combustion. So, to predict the products of a chemical reaction, you need to be able to recognize the type of reaction so that you can figure out what's going to happen in that reaction. And to do that, you have to be able to just look at your reactants and identify what kind of reaction. Again, I'm going to know it's a combination reaction because I'm going to have two reactants and their elements. I'm going to know it's a decomposition reaction because I have one reactant and it's a compound. I'm going to know it's a single replacement reaction because I have two reactants and it's an element and a compound. I'm going to know it's a double replacement reaction because I have two reactants, it's two compounds. And I'm going to know it's a combustion reaction because I'm going to have a hydrocarbon and I have to have the other reactant of oxygen. All right, talking about your homework then. Your homework is on page 224, exercise 22 and 23. Exercise 22 asks you to balance each equation and identify each as the type. So again, you need to both balance them and identify these reactions as one of the 5 types. For number 23, it says, complete and balance an equation for each reaction. The difference between 22 and 23. In 23, they don't give you the products. So you're going to, even though it doesn't say to, for number 23, I do want you to identify the type of reaction as well as one of the 5 types. And then after you've identified that type of reaction, then you're going to predict the products and then balance that equation. Good luck on your homework. I will have a key for you tomorrow, and we'll move on to the next section of our textbook. Goodbye.